Hi, good afternoon. My name is Sebastian Bravo. I'm working with Marilada Pellegrino for Project 2, Dr. Ozbays. I will go ahead and start sharing my screen so you can see what I'm working on. Currently, we're working on Project 2. We're looking at velocity contours, static pressure contours, velocity streamlines, and the drag force and drag coefficients accordingly to the shapes that we have decided to put inside the wind tunnels. So for the last part of this project, it was to place an airfoil of our choice inside the wind tunnel itself. So I decided to choose airfoil NACA 001234. So from here, assuming everything is already inputted in your geometry section of your fluent, we're going to go ahead and begin the process of simulation. So first thing we need to do is go into setup. We're going to go ahead and predis. We're going to say upstream mesh cell has been changed. Yes, it has been changed because we just extruded a cut of the airfoil from the wind tunnel. We're going to have double precision display measure after reading and solver processes as two. We're going to press start. From there, we're just going to give it a couple of minutes to load up. We're going to be using the same settings as the others simulations we ran for the other shapes in order to have similar correlated results. So such as the initial stream velocity, which we have started at 3.05 meters per second. So we will be changing the relative measurements there. And I believe we will be also changing one more thing, the boundary conditions for the inlet velocity condition. So from here, we'll press OK. We're going to go to the boundary condition. We'll open that up. We're going to go to inlet. We're going to velocity inlet. And we're going to change that 1.69 from the prior experiment for project 1 to 3.05. We're going to play apply, close. From there, we're going to go ahead and go to reference values. We'll do the same here. We're going to change the 3.05. And now we're going to go to initialization. And we're going to go to hybrid initialization. And we want it to run an iterations of about maybe 150, just to make sure that it will converge. And from there, we're going to start initializing. This is probably going to be the longest that's going to take, along with calculation. These are going to be the two longest processes for this part of the experiment. Otherwise, everything is a little bit more forward and direct in getting the results. So realize that you will be getting from the setups, you will be getting the contours, and the results section, you will be getting the streamline, and to get the drag coefficients, you'll get it from the results here, or sorry, the setup from here. So give it a moment. It's at approximately around 65 iterations, and it's running all the way to 150. Let's see if we can analyze this further. We can see our airfoil here. We did triangular method for meshing, just because in the prior experiment, project number 1, we used this method and it worked pretty ideal for our results. So we're going to keep it and maintain it there. We are approaching 100. Shouldn't take a couple more minutes until it's done to get to 150. It's approaching 130 out of 150. We're almost completed with this session. Okay, all completed. Now we're gonna go ahead and run calculation. I'm gonna calculate this. So in this experiment, every single answer is probably going to vary from other partners or other projects that other people in this class are doing, just because our airfoil is not the same. And two, because each shape is different in dimensions. There wasn't a certain dimension the professor asked us to create. He just basically said for it to not block the block ratio, which is 10% of the throat of the test section. So as long as it didn't go past 0.7 inches, then we should be all good. However, we decided to make 0.5 inches the maximum height for most of our shapes. And thus that's where we created our basis of dimensions with regards to. However, the processes in order to get these results are all similar. You're approaching 75% completion. We're approaching completion. Cool. The iterations are complete and now they're just pre-screening how our contours will look and our plots. Now, since that's completed, we can go to our plots, I believe. Graphics, my apologies. And then from contours, we can check out the pressures. I think we already have some that are already pre-set up. So for example, this is velocities. So we're going to save and display. Cool. So this is our velocity with respect to this airfoil. Cool. This is our velocity contour. So what we're going to do here is we're going to go ahead and save that to our clipboard and we'll put it back into over here. We'll call it velocity contour and paste it. Now, next we have our static pressure contour. And from here, we're going to go ahead and switch over to static pressure. Change that to pressure. We call it contour 4, static pressure, and we want the static pressure from everything. Save and display. Cool, compute it. And this is our static pressure currently. We're going to go ahead and zoom in. Cool. Now I want to go ahead and control, command save it. Go back here, put our static pressure there. Next, we're going to go ahead and do our drag coefficients. So we're going to go to solutions. From here, we're going to go to, if I'm not wrong, we're going to go to definitions. We'll go to new. We'll go to force report. We'll go to drag. And then from here, we'll get drag coefficient. Compute that. And we'll get drag force, compute that. So down here, you'll get your drag coefficients. First one being drag coefficient. And the next one being drag force. Verify that. Drag coefficient. Drag force. My apologies. Guess I can't spell. I'm an engineer. So once that's completed, we have almost all parts of our project done for this. Only thing we have to do is the velocity streamlines. So from there, we're going to actually exit out of this. We want to quit. Yes. As I want to change for current and future. Yes. And we're going to go to results next. This is setup. Let's give it one moment for it to close out. And then we can go ahead and collect our velocity streamline patterns. Cool. Now we go back to here, not this one. We go here and we go to, is it solutions or results? I'm gonna say results. We're gonna press edit there. Cool. And now our mesh should appear in a moment. Nice. With our extruded airfoil cut. All right, there we go. So this is ideally how our wind tunnel will look with the airfoil in the test section. So from here, what we're going to do is we're going to go up here, and we're going to press this streamline one, and press OK. From here, we're going to go ahead, say, start from velocity inlet, which is the beginning of the wind tunnel. We're going to say, instead of equally spaced, we'll say vertex, max number of points, and we'll put it to be 25. We're going to go ahead and do direction forward and backwards. The variable is velocity. Now we should see a streamline pattern approaching here. Cool. So this is our streamline pattern right now for velocity. And this is our airfoil. If we were to increase the amount of streamline, I guess we'd be able to see better how it reacts. So let's see if we put 75 instead. You can see airfoil is going around. I'm sorry, the streamline is going around the airfoil. Now, if we even increase it further to 100, we'll see a better depiction of it. And this will also look like our velocity contour, by the way. So what I'm going to do here is I'm going to go ahead and down it down and put to, I'm going to put 30, just because I want to demonstrate that there is a streamline going on. So from here, we'll do that, apply, and then from here, we're going to go ahead and press right click, we're going to place save picture, and we're going to go ahead and control C that so we know the location of it. And from here, we'll press save. And now we have our last part of this. Now next, we're going to go to here, we're going to go here, control V, you're going to go to user airfoils, and you're going to look at the last one, and you're going to press control C. Now you go back here. And we have our velocity streamline. Now we're ultimately finished with the project. I guess the only thing I'm going to do now is just create a table of values depending on each figure that we created for the coefficient of drag and coefficient and the drag force itself. So thank you for watching. My name is Sebastian Bravo. I worked with Mari Laura Pellegrino for this project too. Thank you very much.